Hi guys, welcome back. Let's keep moving on with activity 95. Yesterday you worked on the peppered moth and what happened to the peppered moth, and based on your scores on the exit ticket, most of you really understood what happened. You saw that the peppered moth changed because of the environment. That mutation always existed. The black peppered moth was not successful in a clean forest, but because of the soot from the Industrial Revolution, we saw the population change. And hopefully, whenever you did the simulation with the birds, where you got to be the birds, you were able to see how that could actually change the population. So we're just going to keep moving on a little bit. I'm going to give you a few examples and ask you to write a few answers in your notebook as you go. So again, just pause as you need to stop and write when I ask you the question. Okay, so let's pretend we have a population of worms, and some worms are lighter and some worms are darker. They come in two different colors, and birds eat the worms, obviously. Most of the birds that eat the worms are better at seeing the lighter worms. The lighter worms stick out a little bit more. So, which worms do you think are more likely to be eaten? And what do you think would happen to the color of the worm population over lots of years? So, take a second and think about that, and think about why. Whatever you say would happen to the worm population, ask yourself why that would happen and jot down a few notes and pause the video. And then when you're ready, you think you have a good answer, unpause, and I will move on to the next slide. Okay, so remember, most of the birds see the lighter worms better. So the lighter worms would be more likely to be eaten. And because the lighter worms are eaten, you would expect their numbers to be decreased. The darker worms would be better camouflaged, so they would be better suited to their environment. Um, the darker worms would be more likely to survive and reproduce. And over many generations, you would assume that the lighter moths would die out slowly over time. And eventually, you would have either almost all or completely all dark worms. That's very similar to what we saw with the peppered moth, okay? It wasn't that the worms decided to be different colors. Those colors always existed. It's just in their given environment, the environment chooses which worms stick out based on the predator-prey situation. So then we want to stop and say, okay, well, what if the environment changes? So let's say the environment changes and now suddenly the dark worms blend into their environment and the light worms suddenly blend in. And maybe it's like a lava flow like we saw with the rock pocket mouse. So now all of a sudden the environment is dark and the dark worms blend in. What do you think would happen to the worm population? So again, pause, come up with an answer, and make sure to try and explain to me why you think that would happen. Okay. So, what you should have come up with is that if the environment changes, which type of worm that is better suited should also change. So, if the ground changes to dark, now I'm sorry, I said that wrong. So, it's not that the ground changes to dark, it's that the lighter moths are going to blend in. So, let's say that the ground is lighter now. So now the lighter moths would be suddenly better suited to survive in that environment, and they would be more likely to survive and reproduce. It's just opposite of what we did the first time. And now all of a sudden the dark moths are less likely to survive, and they would see their numbers go down and potentially go extinct if left long enough. Okay. So since we're talking about worms, in class we were supposed to do a lab, and we would have simulated that exact example with worms on different color environments, and you would have got to play a game to see. You would have been the birds, and you would have pretended to eat these plastic worms, And we would have actually shown that with data and numbers. But let's talk about real earthworms. So why do you think earthworms are beige and not green? Because they do live on the ground and the ground is covered with grass, but earthworms aren't green. When you look at them, they have that brownish tannish color to them. So stop and ask yourself that question. Write an answer in your notebook. Make sure you restate the question and then pause. And when you're ready, unpause and I'll give you the answer. Okay. Earthworms have camouflage, and presumably their colors have evolved to match the kind of ground that they live in. Earthworms actually come in a couple different varieties of colors, and so you can see this earthworm's a little bit lighter. It probably blends into this kind of lighter soil, more like a clay. Whereas if you have a darker soil, the edge of the earthworm is typically darker colored, and that helps it to blend in when it sticks its head out. This is the head end of the earthworm. Just a fun fact, this little band right here on an earthworm is known as the clitellum, and it is always closer to the head side of the worm. See, that's how you can always tell which is the head and which is the tail. So the head is always a little bit darker so that when the earthworm pops its head up out of the ground, it's a little bit more camouflage and less likely to be seen by a predator. If you take that same worm and put it on top of the green grass, it doesn't blend in and it would be a lot easier to get picked off. And think about whenever the birds come and eat the worms after we've had a lot of rain, the earthworms have to come up to the top so that they can breathe. And the predators will come and just pick them off because they're up. If you're a fisherman and you go out and catch your earthworms at night, the night crawlers, it's easier to find them when they come up at night and are on top of the grass instead of down in the dirt. So their camouflage is an evolutionary advantage for them so that they can blend into their soil. Okay. That's it for today. We're just about done with activity 95. I want you to, when you get out of the video, I want you to go back into the classroom, go into your classwork section. I have one more camouflage exit ticket for you. It's just a few multiple choice questions. I just really want to make sure that we're all on the same page and understanding what we should have learned about camouflage and natural selection. If you are struggling or you feel like you really don't understand, I really need you to shoot me an email and let me know. I can always set up times to chat with you one-on-one. We can do an audio call or something like that so that I can help fix any misunderstandings or miscommunications that you have. But you have to let me know. That way I know that you need my help. So go ahead and do the exit ticket, and then I will see you tomorrow. Okay, thanks, guys.